All right. Thanks. Sorry for the confusing start of this live episode. Basically, I had connected to the wrong Wi-Fi network, which wasn't streaming very smoothly, and that's the issue of live streaming. Welcome to. There we are. This is the official start. Welcome to Python Live Lessons episode 2, the third episode of Python Live Lessons. So this is a weekly show about Python code in which I will introduce various issues related to Python programming, but also more generally related to managing software projects. And today we're actually going to take a look at how you can build a Python package or a Python module. And when I say a package, I don't mean that we're going to build a package that we're going to actually upload and that you can install directly, but just sort of the internal file and folder structure that makes up a Python package. As always, I'm very open to questions. So if you have a question, please post them in the chat, and I will try to engage as much as I can with questions. All right. So the program that we're going to make is called Markdown Code exec. We did that in the first and the second episode 0 and 1. And the idea, and we've already implemented this, is that we have a piece of Markdown code such as this, and that this Markdown code contains text contains code. In this case, a little bit of Python code that says print hello world, and then our program Markdown Code exec is supposed to sort of take this text, parse it, and then actually capture the output that is generated, in this case very simply just hello world, and embed that in the output of the file, right? So we're basically compiling in a way Markdown files by capturing output of code and including that in the Markdown. I hope that idea is clear. And in the first two episodes, we basically created a code sketch in which we created a program that actually does this. And we looked first at regular expressions, and then at the function in the first episode 0, and then at exec and eval as functions to execute code in episode 1. So where we are now is that we have a fully functioning code sketch that I will show you in a bit, that actually does what we want the program to do, roughly. So most of the functionality is already there. And what we want to do today is go from this sort of rough code sketch to a real Python package or a Python module that we can import and use in the regular way, right? So right now we have something that's a bit sloppy, just a sketch, and we want to polish it into something nice. All right, so let's actually switch to the editor, and let's go to work. So here we have the code editor. I will zoom in a little bit. Yes. And what we have here is basically a little thing that reads, a little code sketch that reads a Markdown file. If I execute that, we will read it. And then we can take a look. What are we actually reading? It's this file, demo.md. And it is just a Markdown file. I'm assuming you're familiar with Markdown, Markdown syntax. It is just basically a way to combine text like this with sort of code snippets like this, some more text, etc. And here we have a code snippet, therefore of which we have indicated that it is Python code and that we want to capture the output. And that is what our code sketch does. Basically, it captures that output. So right now we've demoed the contents of the text file into MD, a variable called MD. And then we created this elaborate code sketch, which is pretty complex, but we've already done that. So watch the first two episodes if you want to know how that works. And what it does is basically it takes that demo.md and it compiles it by including the output of those code blocks in a new Markdown file. So if I run this up, you will see it actually doesn't give any error messages. And what we get is a variable called mdout. And if we take a look at mdout, we can take a look here in the variable inspector here. We will see that our code sketch does what we want our code sketch to do. right? So if you take a look here, we had this little thing that we wanted to capture. And then we have an output marker. And here we have actually successfully captured the output. So in a way, we're done. The job is done. We have a code sketch that actually does this. What I want to focus on today is not so much how this works, but how we can take this piece of code here and turn it into a Python module, a Python package that is actually very easy to use, right? So that you can use it in this, you can import it and actually execute functions from your module, from our self-created module. Now, and then to know how that works, we need to kind of understand how in Python modules and packages are structured. Now, a Python module is very simply a file, a Python file. So let's say that we want to have a Python module. I say, okay, I want to have a new file, and I call it Markdown Code exec. So, and just we started a little bit in chaos because I failed to connect and I was panicking here to the YouTube live stream, but now I've regained myself, and I want to remind you, if you have questions, post them in the chat, right? I have the chat right here. I'm monitoring the chat, and I will try to engage anything you say. All right. So right now I created a file called Markdown Code exec, and if I double click on it, it is empty. It's an empty file, and this is a module. It is a Python file that has a name. So a module is just a Python file. And then what we can do, we can go to the sketch and we take all of this complicated code that we created in the previous episodes, and I post it here in our new module. So far, we haven't functionally done anything different from creating the code sketch. But of course, in a module, generally speaking, you will have functions. And then you can call the functions from the module. Now, what functions do we want to have? I think it makes sense for the purpose of our code program to have two functions. One function that is kind of like the basic function, and I will call it def parse text. And it will take basically a markdown file as input, and it will return a markdown file with all the output parsed as the return value, right? So basically it is what we implemented here, and then the return value will be md out. I hope you understand the logic here. So we've created a function called parse text, and the body of that function literally is just the stuff that we created in previous episodes. I literally copy pasted it, but now I put it inside a function. And at the end of the function, rather than just letting md out vanish into nothing, we return md out here as the return value. And as such, we have a function that we can use. Now, if you are sort of have a sense of style, coding style in the way that I do, or I believe I do, there are some things that are not nice here. One thing that is not nice is that import statements should actually be at the top of the file. It's not nice to put them inside a function. You also see that pattern here is actually something that we don't change. It's just a static value. So it would be nicer to actually indicate that this is a constant pattern by giving it. And then of course, when we use it inside the function, we should also And now we have changed nothing functionally, but we have adapted it a little bit to meet sort of Python coding guidelines. And what are Python coding guidelines? Well, that generally speaking, you have import statements at the top of the file. If you have variables that have a static value so that you don't really change them, you call them constants, and you use an uppercase name to indicate that you shouldn't change their value. You can, but it would be impolite to do so. That's basically what a constant means in Python. And other than that, we've left everything the same. Now, I think in addition to having one function that parses the text, I think it would also make sense to have like a higher level function that actually takes an input file and an output file, and actually reads the text from the input file and writes it to the output file. Because generally speaking, that's what we want to do, right? We generally speaking want to operate on content of files. All right. So how does that work? Then let's say we don't call it parse file, but we call it text, but we call it parse file. And we say source and dest, where source will be the source file and dest will be the destination file, and those should be paths to files. Then we basically say, okay, let's first with open source sfd md is fd.read. What does this mean? We just open the source file for reading, we read all the contents from the source file, and we assign it to the variable md. Now, then we say md is parse text md, right? So we parse the text file, and then we actually need to write the results. So we say with open dest sfd fd.write md. So we do approximately the same, but to open a file for writing, we pass the W flag to say that we want to write to it. And then we write basically the parse text to it, right? Very simple, high-level file that uses basically our parse text. So what do we have now? We have a module that is called Markdown Code Exec. And our module contains two functions, parse text and parse file. And those two functions we can use basically. How do we use them? Well, in exactly the same way as we can use as we would use any kind of function. So let's just actually use it manually. So I open here the interpreter and we can say from Markdown Code Exec import, and then we can say parse text, parse file. This should work. And now what we've basically done, parse text corresponds to the parse text variable function here, and parse file corresponds to the parse file function in here. So this, if you want to structure your code, for example, say that you're doing data analysis, if that's what you're doing, and you find yourself having a lot of stuff basically in a very massive analysis script, then it would make sense probably to create a few modules, and then you put some of the code in those modules so that you sort of have your analysis script a little bit lighter and more focused on the conceptual parts, and then you have a module that has a lot of details in it. I hope you kind of see what I mean. And then Igor says, let's check MD for null. And I don't exactly know what you mean, Igor. Perhaps you mean that it is possible that parse text actually, or that maybe that we are sort of reading something empty. Your general point is well taken. This is a very unsafe program that I made here. It is unsafe in that we basically not checking if source exists. So if source doesn't exist, it crashes. Maybe it exists, but it doesn't have any text in it, and it will be empty. Or maybe it exists, but we're not allowed to read from it, and this would crash. There are all kinds of things that are going wrong here. And let's just, why not actually? Just let's give one example of how you can make this safer. I'm not going to extensively make this a very safe code because it would take a lot of time, but just one example. Let's say, okay, if do we import? We say import OS. If not, os.path.isFile source raise value error is not a file. So this would be one example of how to make things. Or we could also use try except statements. That's fair enough. Yeah. All right. Igor is schooling me here through the chat. That's very good. So what we're doing here is basically building in some safety checks, right? So we're making sure that source is actually a file and not, for example, a directory or folder. And if it is not, we crash with the value error saying that source is not a file. We could also have something else. We could say that this would go wrong. We could say try this except file not found error And then we say, okay, return none, for example. What would happen here is then if actually the file is not found, then we actually have the function return none. Is that useful? Maybe not. I don't know. But there are various ways. Basically, you have to think for yourself, how do I want my function to behave when it gets input that doesn't make sense? And then you build sanity checks that actually match that. That is the logic. So for now, let's actually just make sure that we're allowed, that we're actually source is an actual file. And other than that, we just leave it at that. Right. Okay, so now what we have is a module. But there's a distinction in Python between modules and packages. And the distinction is simply, essentially, the distinction between folders and files. So a Python package is a folder and a Python module is a file. That's essentially all there is to it. So let's turn this, it's not necessary, but just to show you how you could do that, let's turn this into a package rather than a module. So the first step is to say, okay, we're going to create a folder directory. And I call that folder also markdown code exec. Up. To indicate to Python that a folder is a Python package rather than just a folder that contains whatever, it needs to have a special kind of file inside of it called dunder init dunder. And what does dunder mean? It's just 2 underscores. So underscore init underscore underscore init underscore underscore .py. As soon as you do that, now magically this folder is a Python package. Bam, it's a Python package. Then we actually take our module and I say I cut and I paste it into the markdown code exec. And I will show you basically, let me show you something and then I will explain it. This is how I usually do it. This is also in part a matter of style. Inside the package, I create a file underscore markdown code exec that contains the actual functions. It's just a thing that we made before, right? Nothing special. But I would like my package, so I could import this as saying from markdown exec dot underscore markdown code exec import parse text. But I don't like that. That's ugly. I just want to be able to do from markdown code exec import parse text. Now, how can you do that then? Well, we can use this init file for it. So let's open that. And here I'm going to say from markdown code exec dot underscore markdown code exec import parse file and parse text. So what does this do? Basically, it takes, you have to think of this as sort of in the init file, we sort of import the parse file and parse text functions that actually live here in the markdown code exec module. But by importing them into this init function, we make them available directly under markdown code exec. So now we are able, again, to say from markdown code exec import parse file. And then what we would be doing is actually, we say from markdown code exec, so the package here. Then we check inside the init whether there's a parse file. There is actually, but that parse file is actually located in a submodule, you could say, underscore markdown code exec. And this allows you to sort of structure your functions in sort of submodules, but still making them more globally available. I hope that makes some kind of sense. If it doesn't, please ask questions in the chat. And because I like to be very organized, I will also say underscore underscore version underscore underscore is o.o.1. Well, let's be generous to ourselves. Let's say o.1.o. And this is kind of a Python consensus that there is a underscore underscore version underscore underscore variable that lives sort of in the top level. And it contains a particular value. And that is sort of how the module, how the package, identifies its version. Now let's see how this actually works. Let's actually go to town on this. So I'll go back to the sketch. Up. I'll create a new cell for myself. And what I will do now, I will say, I will restart the kernel because we've changed stuff about about the way that packages and modules live. And if you don't do something special, if you have already imported a module and then you change that module, then those changes are not automatically sort of re-imported, if you see what I mean. You have to change the kernel, or you have to do, and that's what I will do here, tell the Python interpreter, this only works in IPython, loadExt auto reload. So what I'm doing here, this is something that doesn't normally work in regular Python. It doesn't work in a script normally. It doesn't work if you type it into a normal Python interpreter. But IPython, so this Jupyter IPython kernel, understands this as a special magic command that says load the extension auto reload. And that is a super convenient extension because it means that if we prefix code with auto reload like this, it will actually, now it's complaining, hey, that's not valid Python. That's true. But it means that if we execute this, if we basically decorate our code cells or the things that we execute with this, it means that whenever a module has changed, that change will be automatically reloaded. And if you're working in an interactive environment, like an IPython notebook, or sort of the way I'm doing this here on Rapunzel, that is super convenient. I hope that makes some kind of sense. Now, let's actually see whether this works. From Markdown code exec, import parse file. And then what I want to do, I want to say parse file, which file? Demo.md. And I want to parse it to demo.out.md. Up. And I will click here to execute this code cell. Bam. Here it is executed. Does it work? Well, let's take a look. We now have a demo.out file. And if everything went correctly, this should basically be identical to our input file. But now it should actually have the output of the code snippets included. So let's take a look. Let's put them side by side. Here on the left-hand side we have demo, so what we gave as input. And on the right-hand side we have demo.out. And did we do this correctly? So here we have the print statement that should be left alone because there is no capture flag that indicates that the output should be captured. So nothing happens. That's correct. Here we have another code block that is Python code and the output should be captured. That's what this means. And why does that work? Well, it works because we have implemented our code sketch in the first 2 episodes to actually understand what this means. And here we have actually you see that it works, right? We've captured the output, created a nice output prefix, and here it is. Then here we have another one. Here we have Python silent. That means, because we wanted it to mean that, that's how we designed our code sketch. That should mean that this code is executed. The output should be captured, so a silent cell. And the whole code block should be replaced by the output, right? So now we should no longer have this, but we should only have a silent cell. And that works. And here we have our third special case that we designed, where we capture the output and with the exception flag we indicate that we actually expect this to crash. That's how we designed it again. We run some code that crashes, right? If I run this, you will see that crashes, of course, gives a value error because we're trying to turn the letter X to an integer and that's not possible. It's not an integer. And then you see that indeed the output that is captured here is the error message, basically the error message of the exception. So I hope that now you see that actually building modules and packages in Python is super easy. So what have we learned? We have learned that a module is just a Python file with basically usually functions inside of it. A package is a folder that contains an __init.py function, and usually either stuff is defined in this file, but more often actually there are other files that live inside that folder, in our case _markdown code exec, that contain the actual functions. And then you can use the __init.py to basically sort of determine how you want how you want to expose the functions to the outside world. I hope that makes some kind of sense. All right, so that went reasonably fast. You see that now actually in 3 episodes of about 30 minutes each, we've implemented something that I think is fairly complex, but it works really well. In the next episode, what we're going to do is actually turn this in. We are going to use Git versioning to actually keep track of our code, because I think right now we're at the stage where Git becomes in handy because we want to sort of properly manage this as a code project. And we're also going to change this into something that we can execute from the command line, because then it will be extra sweet, right? That we actually have a command line application. And Nipodem says, I would like to ask about Django, specifically how routers work, because I can't wrap my head around it. Oof. Well, I know I said that I'm very open to all questions, but this goes a little bit beyond the scope of this particular episode. Django, for the other people who are watching, is a sort of a server framework for Python that is used a lot. Basically, a lot of web servers that run Python use Django. Let's say, Ni, that I'm making a mental note here, and maybe we can address this at some point in future episodes if there's an interest in Django. I hope, but that's the best I can offer you right now. Other than that, this concludes the regular part of today's episode number 2, the 3rd episode. If there are other questions, I will engage with them in the chat. And for the people who are watching this episode back, thank you for watching. Atishay, can you please include classes also? I would like to see, practically speaking, what you need to use classes. All right, that's actually a really very good point. So classes are certainly a topic that we can address in future episodes. Actually, I have a playlist about object-oriented programming. So not live, but you can maybe already watch it, that is about classes. So you can take a look at that. And Siet asks how to make our package downloadable by pip. I'm very happy you asked that, Siet, because we are definitely going to address that in future episodes. The trick is, I will spoil sort of I will give a spoiler. The trick is, generally speaking, to make a file called pyproject.toml, and you define a few things in that file, and then very easily you can upload to pip. It is really, once you know how it works, it literally is 5 minutes work. And we are going to do that, and we are going to work towards a pip installable Python package that you can execute from the command line and run as a module. Oh, and I see Atishay already saw the tutorials about classes. All right. I see no more questions in the chat, so I'm talking slowly just in case final questions are streaming in. There is a 10-second or about a 20-second round trip time. If there are no more questions, then I would like to thank you all for watching. Spread the word. I'm sure you can see that there are not that many concurrent viewers. There are quite a few people watching it after the fact, but I would also like to have some questions live. That's why I'm doing it live. And I will see all of you next week for Python Live Lessons 3, the 4th episode. All right, enjoy the rest of your evening or your day or your night, whatever the case may be in your time zone. All right.